This 2018 Leaving Cert Higher Level question 8 on paper 1 was this symmetric function f of x is equal to 1 over the square root of 2 pi times e to the power of minus a half x squared, which is your normal distribution curve. Part A asks you to find the point A in terms of pi. Now, because we can see this x and y axis here, the intercept at this point at A, x is equal to 0. So if we put 0 in here, we're going to get e to the power of 0, which is 1. So the point A is equal to 0 for my x, and my y value will just be the 1 over the square root of 2 pi. Straightforward enough intro to this question. Part B asks us to find the area of the shaded region, and it tells us that B is minus 1 over the square root of 2 pi e. So this value here is minus 1 for x, this length is 1 and this length is 1. We have the height, which is the y value, so the area is equal to twice 1 over the square root of 2 pi e, and they ask for this corrected 3 dp. So just type this into your calculator and you're going to get 0.4839, which is 0.484, and that will be in units squared. Part C, we're asked to find or show calculus to show that the function is decreasing at C. So calculus to show f of x decreasing at C. So we will have to show that f prime x is less than 0 for this to be the case. So just write f of x down again. You can see it here, 1 over the square root of 2 pi times e to the power of minus a half x squared. So when we differentiate e to the power of x, it goes to e to the power of x. E to the power of 2x goes to e to the power of 2x times the differentiated power, which is 2. So we're going to have to differentiate this power here. Minus a half x squared, what will that go to if we differentiate it? Well, the 2 by minus a half is minus 1, or so just minus 1x, or minus x. So we'll need that now. So f prime x is, well, this is just a constant in front of e, so that stays there. 1 over the square root of 2 pi times e to the power of minus a half x squared, and then multiplied by minus x. And we need to find what this point C is, which I should have wrote here, point C. Point C, well, it's symmetrical. So it's the same as point B, only instead of having a minus 1, we're going to have a plus 1. So 1 and 1 over the square root of 2 pi e. So what we need to do is we need to put our x value in to show that this f prime x is less than 0. Now we can see here, this is a positive number, 1 over the square root of 2 pi. So is e to the power of minus a half. So this will give me a 1. So we can put the whole thing into our calculator. We'll see that it comes out as negative because we're going to be multiplying these two positive numbers by minus 1. So 1 over the square root of 2 pi times e to the power of minus a half by 1 squared, just minus a half. And then multiply your answer by minus 1. This minus x is minus 1. And it comes out to be, gives minus 0.24, which is less than 0. Therefore, at the point C, the function is decreasing. Part D of this question, you're asked to show that the graph has a point of inflection at the point B, which I've taken from above as minus 1 and 1 over the square root of 2 pi e. So this is what we need to know for this part. If a function has a point of inflection at a particular point, x is equal to c, then f prime prime c, or the double derivative, is equal to 0. So we need to find the double derivative or the second derivative and put minus 1 in here, and we should get a value that's equal to 0. So just let's take our function down again. Well, we have the first derivative here, So 1 over, was the whole thing multiplied by minus x, 1 over the square root of 2 pi. Times e to the power of minus a half x squared by minus x. Now you should see here, this multiply makes this a product rule question, because we have two x's in each part. So the first by the second differentiated, first by dy dx of second, and then we're going to add the second by dy dx of the first, and the order doesn't matter here. So the first is from here to here. So f prime prime x is equal to 1 over the square root of 2 pi times e to the power of minus a half x squared, and then we multiply by the differentiated second, which is just be a differentiate minus x, we're going to get minus 1. Then we're going to add the second by the differentiated first. The second is minus x, and the differentiated first is going to give me, well, the same thing again, isn't it? 1 over the square root of 2 pi times e to the power of minus a half x squared by minus x. So if we tidy this up, well, these two are going to give me an x squared. So we have x squared multiplied by this whole function, and we also have minus 1 multiplied by this whole function. So that's going to give me x squared minus 1 multiplied by the function itself, 1 over the square root of 2 pi by e to the power of minus a half x squared. Now, so that's f, the second derivative, or f prime prime, whatever way you say it. So if we put minus 1 in, you can see what's going to happen here. F prime prime minus 1 is going to give me minus 1 squared, which is 1, take away 1, which is 0, times the function itself, which we can see, sorry, the 2 pi is inside, is going to give me an answer of 0. Therefore, point of inflection at B.